Hello everyone, welcome back to my channel. We are all good at educating. Today in this class, let us learn about the chapter 2 of the class ninth. Chemistry is matter around us pure. You know that in the previous chapter we have learned completely about the matter. We have different states of matter, some experiments, examples, everything we have learned about the matter. So everyone know that matter is something which can occupy space and has some weight, okay, or mass. It is called as matter. The matter can be divided into two types. One is mixture and pure substances. What are the two types? The matter is divided into mixture and pure substances. Mixture is again subdivided into homogeneous mixture, heterogeneous mixture. Whereas pure substances, that is elements, it is divided into elements and compounds. Okay. Matter is something which can occupy space and has some weight. Okay. It is divided into two types, mixture and pure substance. Mixture is again subdivided into homogeneous mixture and heterogeneous mixture, whereas substances can be divided into elements and mixture. So let us learn first detail about the mixture. What a mixture? A mixture is formed by combining two or more substances in which each substance retains its characteristics. Like we have two types of mixture, that is one homogeneous and one more is heterogeneous. So let us learn the details about the homogeneous mixture. Mixture is what? Mixture is a combination of two or more substances. Okay, it is a combination of two or more substances. Homogeneous mixture. The mixture which has the same proportions of its component throughout the mixture is called a homogeneous mixture. That is, it is having the same proportions. That is, whatever the this we are taking the mixtures, we are making different gases, like example solids, whatever we are taking, it will have the equal proportions of both what we are adding. Example we have is, air is a homogeneous mixture because it contains mixture of different gases like nitrogen gas, oxygen gas, and so on. So, in nitrogen gas, oxygen gas, everything will be in the equal proportion. So, it comes under the homogeneous mixture. We can get the components, that is both the components in the same proportions. Okay, it is called as what? Homogeneous mixture. So, the next we have is heterogeneous mixture. What a heterogeneous mixture? Heterogeneous mixture. The mixture which has the varied proportions of its component throughout the mixture is called the heterogeneous mixture. Like they'll not be in the equal proportion. One may be 70%, it may be 30%, one may be 10%, like that. Even 100% it can be in any proportion. Okay, it is not like 50-50 exactly. Example, we have the soil is a heterogeneous mixture because it contains pebbles, also sand, plant matter, which remains separate in the mixture. So it will not be in the equal proportions, it may be in the varied proportion. So you can see here differences between the homogeneous mixture and heterogeneous mixture. The constituents are mixed uniformly, means the constituent what we are using here, it is in homogeneous, both are in uniformly. Here it is opposite, it is not mixed uniformly. The components cannot be easily seen. Here the components can be easily seen. Next, the components cannot be separated by filtration. Here also it cannot be separated by filtration. Example, we have sugar solution, soda, water. Here milk and blood. So these are the differences between the homogeneous and heterogeneous mixture. That is, they are mixed uniformly, not mixed uniformly. They cannot be easily seen, they can be easily seen. That they cannot be separated by filtration, they cannot be separated by filtration. Next topic is solution. In the last class also we have said about what is solution, how it is formed. A solution is defined as a substances in which two or more substances are completely dissolved in each other and cannot be filtered out. The solution is a special type of homogeneous mixture in which only one type of phase is present. Example, we have lemonade is a solution. So lemonade is nothing but the lemon juice what we are making is called as lemonade. So it is a solution of, it is an example of a solution. Okay, it is a special type of homogeneous mixture. It is having only one type of phase in it. So next we have properties of a solution. First it is, we all know that it is a homogeneous mixture. Second is that particles of the solutions are smaller than 1 nanometer in diameter, so they cannot be seen through naked eyes. So next third point is, it does not show the Tyndall effect, it cannot be filtered. These are the very important properties of a solution. The next, the concentration of a solution is the amount of solute present in a given amount of a solution, or the amount of solute dissolved in the given mass or volume of a solvent. How much volume of solvent we are giving for the solute to dissolve in it. Okay, that is called as the concentration of a solution, and it is expressed in the terms as concentration of a solution is equals to amount of solute divided by amount of solution. That is, concentrations can be expressed in two ways, that is mass by mass percentage, that is or mass by volume percentage. What is mass percentage? Mass percentage is nothing but the mass of solute divided by mass of solution into 100. Volume percentage is equals to mass of solute divided by volume of solution into 100. So one question we have here, that what is the concentration of salt solution which is prepared by the dissolving 50 grams of salt in 200 grams of water? Answer, the concentration is equals to amount of solute divided by amount of solution. The mass of solute of is 50 grams, and the mass of solution is equals to 50 grams plus 200 grams to equal to 250 grams. So the concentration is 50 divided by 250 is equals to 0.2 grams. Okay. So next we have what is suspension solution. Let us learn. Suspension is a heterogeneous mixture in which the solute particles do not dissolve but remains suspended throughout the bulk of the medium. There are some properties of suspension solutions. It is heterogeneous mixture. The size of the particles of suspension is greater than 1000 nanometer. It shows the Tyndall effect. It can be filtered. So these are the different properties of suspensions we have. It is a heterogeneous mixture. So what it is an heterogeneous mixture. Then we have colloidal solution. What is colloidal solution? The colloidal solution is a solution in which particles of a colloid are uniformly spread throughout the solution. What it is? Throughout the solution, the colloidal particle solution, the particles are spreaded. Properties we have here. Like, it is a heterogeneous mixture. The size of the particle of colloid is between 1 nanometer to 1000 nanometer. So it is not visible to naked eyes. It shows the Tyndall effect. It cannot be filtered. So let us learn here some types of colloidal particles. Like, first one is aerosol. Aerosol is a in dispersed phase and dispersed medium. Here liquid is dispersed phase and gas is dispersed medium. Similarly, solid and gas. Foam we have gas, liquid, again gas, solid. Emulsion, liquid, liquid. Salt, solute, liquid. Solid, liquid. Gel, liquid, solid. And solid, salt, solid and solid. So these are the different types of colloidal solutions we have. We have one question here. Identify the type of colloid for the following solutions. Example, rubber and milk. The rubber is a type of foam in which the gas is dispersed in solid. So what is happening for the rubber? We are mixing gas in the solid. Okay. Next, milk is a colloidal solution that consisting of protein, fats and water. So it is a type of emulsion. So it comes under emulsion. Here liquid or protein, fats and water. Okay, it comes under the emulsion. These are the different types of colloidal solutions. Next, separating the components of mixture. We have certain methods here from which the two mixtures or different types of mixture can be separated. The component from the mixtures. First is evaporation. What is evaporation? See, everyone know about evaporation. We learnt in the previous class about the evaporation. Here, salt is separated from seawater by using the process called evaporation. What we does is, evaporation is the process in which the liquid changes its state to a gaseous at any temperature below its boiling point. So what we do is, we take the salt from the sea, and what we does, we make it to dry in the open sunlight. The water present in that salt content, the instrument what we are using, in that all due to the evaporation the water will be dried up, and then last we get the product as a salt. Next we have filtration. Second method, the process in which is used to separate a solid substances from a liquid by allowing the liquid substances to pass through a filtering medium is called filtration. Example, we have filter. What we are here doing, we are separating the solid substances from liquid substances. We can take an example of a tea also. The tea, the solid particles what we have will be separated and the liquid will be separated. Here they have given an example here. the process, it is a process, the liquid is allowed to pass through the filter paper attached to the funnel. The liquid will pass through the paper while the solid will remain on the filter paper. Example, you can get it easily about filtration. The next we have the centrifugation. Centrifugation is the technique in which the mixture is separated through spinning and the denser particles are forced to the bottom while the lighter particles stay at the top when the spun rapidly. So you can see the centrifugation when we does a blood checkup. Okay, what we does is the component, we want to know the component. So what will happen, the heavier components, what will do, the heavier components will settle down, whereas the light components will stay up. From this we can get to know by the using the centrifugation method, we can know, we can separate the denser medium particles and the lighter particles. Okay, the next we have is separating funnel. Separating funnel, it is the immiscible liquid can be separated by using a separating funnel. That is, the particles used in separating the funnel is based on the different densities of two liquids. The denser liquid is settled at the bottom of the funnel while the lighter liquid will remain on the top. Example, we can take up the kerosene, water, and then we have oil. So which is having more density will be in the higher position, which will have less density will be in the lower position. Okay, in this way higher densities will be in the higher and lower will have the lower. In this way we can find by using the separating funnel. Next we have sublimation. So sublimation is nothing but the process in which solid state changes directly to a gaseous state without converting it to a liquid. It is called sublimation. The process is generally used to separate sublimate volatile components from non-soluble sublimate impurities. Ammonium chloride, iodine, naphthalene, dry ice, arsenic, etc. are examples of sublimate solids which change their state from solid to gaseous without leaving any residue. Like example, if you want to know that it is a camphor. See the once it is burned, what will happen? Directly solid will change into the gaseous state without going to the liquid state. Okay, that we can take as an example of sublimation. Next we have chromatography. What is chromatography? Chromatography is a technique used to separate those solutes that dissolve in the same solvent. Like if two solutes are there, both will dissolve in the same solvent, so that to separate that we use the chromatography. It works on the principle of interaction between the solute and solvent. The compound which is more soluble in the solvent can elevate faster, while the compound which has low solubility in the solvent will elute slower. Okay, this is about chromatography. Just you want to remember that what we are doing in the chromatography, we are separating the two substances or two solutes that will dissolve in the same solvent. This is about sublimation and chromatography. This is the diagram of paper chromatography. The next part we have is distillation. What is distillation? Distillation is the method for the separation of components of a mixture containing two immiscible liquids that boil without decomposition and have sufficient differences in their boiling point. It is commonly used in water purification technique. Next we have important is fractional distillation. What is fractional distillation? It is also a type of a distillation process in which the chemical mixture into different fractions using the difference in their boiling point. It is useful for liquids whose differences in boiling point is less than 25 K. The liquid which has low boiling point separates first from mixture of the liquid which has the highest boiling point will separate last. It is nothing but what we are doing, we are separating the two different components which is having less weight will dissolve very faster and which is having more they will dissolve and the later. Next we have is crystallization. The process in which the large crystals of pure substances formed by their solution is called crystallization. It is used to separate crystals from alum, fitachry from impure samples. Crystallization is nothing but what we are doing here. We are separating the pure substances formed from the solutions. What we are doing here, the process in which large crystals of pure substances formed. Okay, so here example we are using is fitachry. That is it's an we call it as an alum. Next topic we have is physical change and a chemical change. A change in which substances undergoes a process to change its physical properties called physical change. What we are doing here is physical change is nothing but it a change in the property. what will happen? Physical properties will change, undergo any changes. It is a reversible process that does not form a new product. For example, stretching of a rubber band. When we stretch a rubber band, what will happen? It again comes back to its place. It is a reversible. Okay. Then next, a change in which the substances undergoes a process to change its chemical composition is called a chemical change. Example, we have in this a new product is formed. In that, new product is not formed. Example, magnesium of a that is a burning of a magnesium ribbon. Burning of a magnesium ribbon will form magnesium oxide. Okay, that magnesium will change to the magnesium oxide. Here what is happening? A new substances is formed, a new product is formed. These are the two differences between the physical change and the chemical change. Physical change means the change is visible, which can undergo the process. Okay, and it is reversible and it does not form any product. Example, rubber band. A chemical change, a change in which the chemical composition, we can see the chemical composition here. It is a irreversible process, a new product is formed, and example, we are using the magnesium ribbon. Next important topics are types of pure substances. Already I said that we have two substances, that is elements and compounds. Okay, so what are elements? See, the substances which has a fixed structures and it is made up of only one kind of particle is called a pure substance. Pure substance is made up of only one kind of particles. It is not a mixture of two or more particles. It is only a mixture of one particle. Okay, no, sorry, it's not a mixture. It is made up of only one kind of a particle. Pure substance is of two types. One is element and another is compound. Element is defined as a basic form of matter that cannot be broken down into simpler substances by chemical reaction. If anything chemical reaction has not anything is happened, what will happen? It will not break down. Okay, it will be the same element. The element is classified into metals, non-metals and metalloids. The substances which contains heat and electricity and is lustrous is called a matter. Metal, well, the substances that is non-lustrous and bad conductor of electricity is called as electricity and heat is called non-metal. See, the metalloids will have the properties of both metal as well as a non-metal. Example, silicon is a metalloid. Next we have compound. The compound is a substance that is prepared by combining two or more elements in a fixed proportion. Example, water is a compound. See, elements are the pure form of substances, okay, and that will not be broken down. It will be in the same form what they are. But compounds are made up of two or more elements, okay, and it will be in the fixed position. Like water. Water is a compound and water is made up of H2O, that is two atoms of hydrogen and one atom of oxygen, that is in the fixed position. The last part of the lesson is the differences between mixture and compound. The mixtures are elements or compound form mixture by a physical interaction. Here compounds undergoes that elements undergo chemical interaction to form compound. Then it is variable composition, it is fixed composition. It shows the properties of its constituent, it will not show the properties of its constituent. Constituents can be separated by physical method, it cannot be separated. The constituent can be separated by chemical method. Okay, this is about the mixture and the compound. This ends your chapter. If you have any doubts, put the question in the comment section. Thank you everyone. Please do like, subscribe and forward and share my channels to everyone.